NEC Section 680.23b tube requires an insulated number 8 conductor to be run in the conduit between the forming shell of a wet niche pull light to the junction box. The number 8 conductor is required to provide a low impedance path for fault currents. This ensures that if a fault occurs in the light fixture, the fault current will return to the panel quickly and safely, preventing damage to the light fixture or other components. The conductor must be insulated to prevent accidental contact with other conductors or metal parts, which could create a short circuit. NEC Section 680.24b permits a pull light transformer enclosure to connect directly to the conduit extending to the forming shell with a listed pull light junction box. Many, including the common automatic transformer, are marked as suitable for direct connection to the pull light. The standard does not require the use of a hub in this instance. Instead, it permits the use of a terminal adapter and lock nut that is suitable for the purpose. The RNC terminal adapter and lock nut typically used for this purpose are designed to provide a secure connection between the conduit and the transformer enclosure. They meet the requirements of 680.24 Bodion by providing a suitable means of connecting the conduit to the transformer enclosure. Let's delve deeper into the specifics of NEC Section 680.23b tube regarding the insulated number 8 conductor. The low impedance path provided by the number 8 conductor is crucial for facilitating a rapid and effective ground fault current path. When a fault occurs within the pull light fixture, such as a breakdown in insulation that allows current to come into contact with the metal housing, this fault current needs to be safely and quickly routed back to the source, which is the electrical panel. A lower impedance path means less resistance to the flow of current. By using a number 8 conductor, which has a relatively large cross-sectional area, the resistance is minimized. This allows for a greater magnitude of current to flow quickly in the event of a fault. The increased current flow promptly trips the circuit breaker or ground fault circuit interrupter GFCI at the panel, cutting off the power supply to the pull light and preventing further hazards. Without a low impedance path, the fault current might be limited, which could delay the tripping of the breaker. This delay could result in the metal parts of the pull light becoming energized for a longer period, posing a significant shock hazard to anyone in the pull. Furthermore, the limited fault current might not be sufficient to trip the breaker at all, leading to a sustained fault condition that could damage equipment and increase the risk of electrical shock. The insulation of the number 8 conductor is equally important. It prevents unintentional contact between the conductor and other conductive surfaces within the conduit or the forming shell. If the conductor were not insulated, it could potentially short-circuit against the metal conduit or the forming shell, creating an unintended path for current flow. This could lead to arcing, overheating, and potentially a fire hazard. The insulation also protects the conductor from the corrosive effects of the pool water and the chemicals used to treat it. Over time, exposure to these elements can degrade the conductor, reducing its effectiveness and increasing the risk of failure. The insulation acts as a barrier, preventing the water and chemicals from coming into direct contact with the conductor, thus extending its lifespan and ensuring its continued reliability. Now, let's examine NEC Section 680.24b concerning the direct connection of the transformer enclosure. This section addresses the installation of pull light transformers and the permissible methods for connecting them to the underwater lighting fixtures. The allowance for direct connection, without the separate listed pull light junction box, offers a streamlined and simplified installation approach in certain situations. Many transformer enclosures, particularly those from manufacturers like Automatic, are specifically designed and marked as suitable for direct connection to the pull light conduit. These enclosures are typically constructed with robust materials and include features that ensure secure and watertight connection. They are also designed to meet the relevant safety standards and are tested to withstand the harsh conditions associated with pool environments. The key to compliance with 680.24 Bodion lies in the use of a terminal adapter and lock nut that is deemed suitable for the purpose. While a standard hub, which is often used for rigid metal conduit connections, is not explicitly required in this case, the chosen connection method must provide a secure and reliable electrical and mechanical connection. The RNC terminal adapter and lock that commonly employed for this purpose are specifically designed to create a watertight seal and prevent the ingress of water into the transformer enclosure and the conduit system. The adapter typically features a threaded end that screws into the transformer enclosure, while the lock that secures it in place from the inside. When properly installed, this combination creates a robust and durable connection that can withstand the stresses of the pool environment. It is important to note that the suitability of the terminal adapter and lock nut must be evaluated based on the specific application and the manufacturer's instructions. The components must be listed or certified for use in wet locations and must be compatible with the type of conduit being used. Additionally, the installer must ensure that the connection is properly torqued and sealed to prevent water from entering the system. In summary, the NEC provides specific guidelines for the wiring and connection of pool lights to ensure the safety of swimmers and prevent electrical hazards. The insulated number 8 conductor serves as a critical component in the ground fault current path, while the direct connection of the transformer enclosure offers a simplified installation method when using approved components and following the manufacturer's instructions. It is important to always consult the latest edition of the NEC and to follow all applicable local codes and regulations when installing or maintaining pool lighting systems. Understanding the rationale behind these code requirements is essential for ensuring a safe and reliable installation. The use of an insulated number 8 conductor for the bonding of pool lighting forming shells is not just a matter of code compliance, it's a critical safety measure. Its primary function is to provide a low impedance path for fault current, ensuring that any stray voltage or electrical fault within the lighting fixture is quickly and safely directed back to the electrical panel, tripping the circuit breaker or GFCI and preventing potentially lethal shocks in the water. The choice of number 8 wire is deliberate. Its larger gauge, compared to smaller wires, offers significantly lower electrical resistance. This low resistance is crucial for facilitating a rapid and substantial flow of fault current. The faster and stronger the fault current, the quicker the protective devices like circuit breakers or GFCIs can react and interrupt the circuit, minimizing the duration of any electrical hazard in the pool. The insulation on the number 8 conductor serves a dual purpose. Firstly, it prevents unintentional contact with other conductive surfaces such as the metal conduit or the forming shell itself. Without insulation, the conductor could inadvertently create a short circuit, leading to arcing, overheating, and a potential fire hazard. Secondly, the insulation provides a barrier against the corrosive effects of pool water and chemicals. These substances can degrade the conductor over time, reducing its conductivity and increasing the risk of failure. The insulation protects the copper conductor from direct exposure, extending its lifespan and maintaining its effectiveness as a safety ground. Regarding the direct connection of pool light transformer enclosures, the NEC permits this practice under specific conditions, primarily when the enclosure is explicitly designed and listed for such use. This allowance streamlines the installation process by eliminating the need for a separate junction box, but it places a greater emphasis on the integrity and suitability of the transformer enclosure and its connection to the conduit. Transformer enclosures that are approved for direct connection typically incorporate features that ensure a watertight and secure connection to the conduit. These features may include specialized fittings, gaskets, and robust construction materials that can withstand the harsh pool environment. The NEC doesn't mandate the use of a traditional hub in this scenario, but it does require that the connection be made with a terminal adapter and lock nut that is suitable for the purpose. This means that the chosen components must be specifically designed for use in wet locations and must provide a reliable electrical and mechanical connection between the conduit and the transformer enclosure. The RNC terminal adapter and lock nut commonly used for this purpose are designed to create a watertight seal, preventing water from entering the enclosure and compromising the electrical connections. These adapters typically feature a threaded end that screws into the transformer enclosure, along with a lock nut that secures the adapter in place. Proper installation is paramount. The installer must ensure that the adapter is properly torqued and sealed to prevent water ingress. They must also verify that the components are compatible with the type of conduit being used and that they meet all applicable listing and certification requirements. In conclusion, the NEC regulations regarding pole lighting wiring and connections are designed to minimize the risk of electrical shock and ensure the safety of swimmers. The insulated number 8 conductor provides a critical low-impedance ground fault path, while the direct connection of transformer enclosures offers a streamlined installation option when using approved components and adhering to all applicable codes and regulations. Always consult the latest edition of the NEC and local electrical codes for specific requirements and guidance.